Dear ladies and gentlemen, let me welcome you to the EAI SmartGov 2020 conference held in this virtual interactive setting. I'm Viltaria Platzner and I would like to address all of you on behalf of EAI and SmartGov 2020. I would like to use this opportunity to address the organizing committee, the authors and all the participants on behalf of all of us here at EAI. I would like to thank all of you for being a part of this conference and for your involvement with EAI. In particular, I would like to thank the General Chair, Sara Paiva, together with the whole organizing committee for their excellent work during the conference preparation. Today, during this streaming, we would like to invite you to participate in a Q&A sessions. During each video, please write your questions about the current presentation into the chat window. After the presentation is done, the session chair will ask selected questions to the authors of the presentation in a live conversation. Lastly, I'd like to use this message to invite you to join us again at the EAI SmartGov 2021. Should you be interested in becoming a part of the next year's conference, please do not hesitate to contact us at the email address below. Similarly, if you are interested in discussing other possible cooperation, a conference, a workshop, or a new event altogether, please contact us at this email address as well. Thank you for your attention and enjoy EAI SmartGov 2020.
Hi everyone, my name is Michal Dudic. I'm the Community Manager at EAI, European Alliance for Innovation. It's my pleasure to welcome you at this conference and say a few words about who we are and what we can do for you and your research career. In short, EAI is a global community for a greener, healthier and smarter world. As of today, we are home to more than 60,000 members from 167 countries, and we reach out to tens of thousands of subscribers. As an organization, we are non-profit from day one, and what is most important to us is that we remain open to all researchers from all around the world thanks to membership that is completely free. We organize more than 100 events annually, such as this conference, and we do so in publishing partnership with Springer. I said in the beginning that EAI is a community, so let's talk about what that means and what it means for you. To put it briefly, we give our members a platform that builds their research. We do it with 3 main online community services where members come together to help each other write a better paper, get an objective review, and get recognized fairly. The 3 services in question are EAI Compass, Community Review, and EAI Index. Firstly, EAI Compass is an online app where you can meet and connect with new colleagues and get feedback on your paper as well as your presentation. In addition to that, it lets you download all full papers that will be presented at this conference, and you can vote on your favorite presentations as well as see everyone who is here and connect with them. You can do this right now if you go to EAI Compass website, compass.eai.eu. Next, we are improving the classic conference review process with community review. It has already been in use at all our events since 2019, and we were very excited to hear a lot of positive feedback from program committee members regarding the reliability and the speed of the community review. Let's talk briefly about what community review does. Essentially, it is a website that shows abstracts of papers that are right in the middle of the review process, as long as the authors allow it, of course. And all EAI members may then bid to review specific papers. When they submit their bid, they put in their bio and their qualifications, which are sent to the program committee, who can then decide whether or not this bidder is qualified to review the paper they bid on. This relatively easy access to review opportunities means that bidders really need to put their best foot forward if they wish to be selected, which improves the quality of the entire review process. At the end of the day, this benefits you, the author. And last but not least, let me tell you a thing or two about EAI Index. EAI Index is our credit-based evaluation system that we rolled out this year to all of our conferences and journals that allow you to climb the global ranks of EAI community and get recognized for your work. It calculates a number value for most actions you make, such as getting your paper accepted or submitting a review, and these numbers accumulate for 12 months. At the end of this 12-month period, we put together a ladder of all EAI members, and the ones at the top receive a nomination to one of the membership ranks: senior member, distinguished member, or fellow. For each action that is eligible for EAI index credits, we'll look at the quality of your action as it was evaluated by another member of the community, such as, for example, the review score of your submission. To make sure that the system is fair to newcomers, every 12 months the credit count gets erased, the ones at the top receive their nominations, and every member starts at 0 for the following 12 months. And finally, Smart Submit is a collaboration feature that is coming later this year. It will allow you to submit your research ideas and your work-in-progress abstracts to get the kind of help and feedback you're looking for. Maybe you are looking for co-authors, maybe you would like to find a mentor or a mentee, or maybe you want to find out how the community feels about your idea. This is what Smart Submit is designed for. Ultimately, it's about helping you write a better paper and increasing your chances of getting accepted. Again, we will be launching this feature later this year, so stay tuned. And so I'm going to leave you with many different ways to get engaged at different levels. There are lots of opportunities in many of our events and publications, which means many ways to connect with people and collaborate. You may learn more about everything I just talked about at our website, eai.eu. These services exist to help you and to make your lives easier, so we encourage you to send us your comments, ideas, and feedback to community@eai.eu. And if you're interested in volunteering and contributing, you can let us know at the same email address. Don't forget that you can use EAI Compass to vote on presentations in real time to determine which ones are the best, as well as to download all full papers that will be presented today. Just make sure that you log in using the same email address as the one you used to register to this conference. Thank you very much for your attention. Please enjoy the conference, and I hope we will see everyone online soon.
Hello, this is Ralf Martin Soe from Smart City Center of Excellence within Tallinn University of Technology, and I'm very happy to present my paper on governance in urban mobility process. This paper is interested in the interplay between smart governance and urban mobility planning in the context of smart city. Mobility is one of the key domains. Thus, it is crucial to analyze the governance models behind it, especially from two perspectives: participation of stakeholders and decision-making procedures. More specifically, this paper takes a closer look at the rather top-down European Commission initiated Sustainable Urban Mobility Plans, or SUMPs, and analyzes how they are designed and implemented in the Baltic Sea region, with an in-depth focus on the city of Tallinn, where interviews with city officials and mobility stakeholders were conducted. The results indicate that the top-down approach has not been taken over effectively by the city officials, and thus creating the lack of ownership on the local level. Tallinn SUMP involved key stakeholders into the planning process, including satellite areas and various interest groups. On our hand, technology-enabled participation of citizens remains weak. The smart city governance as a term is still evolving, and there are several definitions among researchers and practitioners without widespread consensus. However, smart governance as one key dimension of smart cities, helps to reshape administrative processes and structures across multiple city agencies. Involving stakeholders is seen as a prerequisite to successful smart city initiatives. And few authors, starting with Tomor, define, based on the systematic literature review, smart governance as technology-enabled collaboration between citizens and local governments to advance sustainable development. This approach is also applied as a working definition in this paper. In the case of urban mobility, the main challenges have been related to the growing demand for passenger and freight transport due to urbanization, resulting in increased congestion, pollution, and air quality and quality of life. In Europe, this has triggered the European Commission to promote the concept of those sustainable mobility plans, abbreviated as SUMP, especially for the capital city areas. According to authors starting with Maria and others, SUMPs are not new in Europe, but go back decades and have several precedents in larger countries like France, UK, Italy, and Germany. The aim of SUMP is to propose a strategy to reduce the increasing dependency on private cars and thus also reduce carbon dioxide emissions. These plans are usually designed for 10 to 15 years. According to the European Commission, sustainable urban mobility planning is the most important topic in the urban mobility package. The SUMP concept foresees that plans are developed in cooperation across different policy areas and sectors, across different levels of government and administration, and in cooperation with citizens and other stakeholders. According to this concept of European Commission for Sustainable Urban Mobility Plans, the key characteristics of SUMP are it has a central goal of improving accessibility of urban areas and providing high quality and sustainable mobility through and within the urban area. It regards the needs of a functioning city and its hinterland rather than a municipal administrative region. This also means that SUMP is accessible and meets the basic mobility needs of all users. A SUMP presents or is linked to an existing long-term strategy for the future development of urban area and, in this context, for a future development of transport and mobility infrastructure and services. A SUMP equally includes a delivery plan for short-term implementation of a strategy. This should also include timetable, for example 3 to 10 years, for implementation as well as a budget plan. The development of a SUMP is expected to be built on a careful assessment of the present and future performance of the urban transport system. This should also involve suitable performance indicators, specific performance objectives, and targets. SUMP fosters a balanced development of all relevant transport modes, while encouraging a shift towards more sustainable modes. The plan puts forward an integrated set of technical, infrastructure, policy-based, and soft measures to improve performance and cost-effectiveness with regard to the declared goal and specific objectives. This includes, among others, a plan for improving public transport and also non-motorized transport. The development and implementation of SUMP follows an integrated approach with a high level of cooperation, coordination and consultation between the different levels of government and relevant authorities. The local planning authority is expected to put in place appropriate structures and procedures. A SUMP follows a transparent and participatory approach. So once again stressed. The implementation of SUP should be closely monitored, and local planning authorities should have mechanisms to ensure the quality and validate compliance of SUMP with the requirements of the concept. This is essentially a qualitative case study of the city of Tallinn, which is the capital of Estonia, transport planning process based on the document analysis. Documents coming both from public and project-related ones, coupled with expert face-to-face or online interviews of the key stakeholders. Conceptually, the design reality gap method is applied, developed by Richard Hicks, and mainly used in the field of e-government, with some modifications for this research papers. In the context of this paper, the design means the model or conceptuations and assumptions built into the project designs to be applied ex ante, and the reality represents the actual realities of the situation applied as ex post. The success and failure therefore depends on the size of gap that exists between realities and design of a project. The larger the design reality gap, the greater the risk of failure. Equally, the smaller the gap, the greater the chance of success. According to Hicks, 7 dimensions summarized by ITPOSMO acronym are necessary and sufficient to provide an understanding of design reality gaps. And this acronym stands for information, technology, processes, objectives and values, staffing and skills, management systems and structures, and lastly, other resources including time and money. According to the initial project plan, the Tallinn SUMP is a prerequisite for future transport infrastructure projects in the capital region, as the European Commission plans to demand SUMPs for all future European Commission Cohesion Fund investments. When preparing the SUMP, public sector officials are expected to finalize the mobility needs of their region and have set the sustainable transport priorities for its transport investments. As the SUMP design includes review phase after implementation, this is expected to guarantee the continuity of the mobility planning in the Tallinn capital region. In addition, Tallinn planned to learn from Helsinki region mobility plan process, where already second SUMP was approved before Tallinn started its process. So Helsinki is a capital region of Finland and is 80 kilometers away from Tallinn over the sea. The Tallinn SUMP was expected to be a role model process for other Estonian cities and urban regions, as all of them have to start to prepare for the future European Commission transport infrastructure and mobility investments requirements where an existing and high-quality SUMP is a key element. Importantly, stakeholders and participants were expected to be invited to the process of developing the plan, and various digital technologies were planned to be applied. In addition, the approval of SUMP in the city councils of participating municipalities ensures that commitments are followed in the activities phase of the SUMP. Interestingly, Tallinn Region Mobility Plan was planned to be harmonized with Helsinki Region Transport Strategy and operational plans. This was supposed to allow for planning and management of international aspects of the traffic, as well as cross-border traffic between the countries and regions. Issues like intensive goods and truck traffic through both cities in Estonian private car approaches to Helsinki airport in Finland were planned to be addressed jointly. According to the final publication of SUMP, introduced publicly in April 2019, the city of Tallinn contributes to 50% of the total mileage, carbon emissions, and traffic accidents in the entire country. This trend is projected to increase as the population of Tallinn is foreseen to increase 9% by 2035. Whereas Estonia in general does not grow in population, rather is projected to decrease. The key challenges are related to increased costs of mobility, deepening tendency from private cars, too high risks of injuries of pedestrians and cyclists, and negative health impact due to congestion. Most importantly, if no strategic decisions are made, CO2 emissions are expected to continue but are already now 40% above the Estonian target for 2030. In this slide, 3 scenarios were modeled until 2035. First scenario was business as usual, or BAU 2035. And according to this, no major intervention and change in policy. Number of private cars continues to go. There is a need for major investments into roads, and there might be financial penalty for missing carbon emission targets. The second scenario was public transport prioritization, and here PT 2035. According to this, priority of investment is to improve accessibility and secure service quality of the public transport. Planning hubs for better links between different modes. Prioritization of public transport on main directions in city center. And improving walkability and cycling opportunities. Third scenario was Helsinki SUMP projected to Tallinn, and here as HEL 2035. And according to this, the SUMP goals of neighboring capital city of Finland was projected to Tallinn, and this 2018 scenario shows the status quo. So, in order to analyze the SUMP process in the context of smart governance and the design reality framework, interview results are presented now. According to this ITPOSMO framework. In the case of information, urban mobility information was central to the SUMP planning in Tallinn. Therefore, various mobility data was gathered, including typical daily routes of citizens, for example, home to kindergarten to work, means of transport, public transport, car, walking, cycling, and other aspects, for example, parking. The SUMP utilized some digital data collection tools, for example, mobile positioning for tracking urban mobility, people tracking sensors in public transport, although some remained unused, for example, satellite-based parking lots mapping. On the other hand, there was no digital decision-making tool applied before the final stage when the process was sent to the local council in Tallinn, where all decisions are open for online consultations and later published online. Therefore, during the preparation period, the information stayed within the core project team, although it should have been more widely spread. In the case of technology, the initial aim was to provide a decision-making tool based on the measurable mobility indicators, which did not succeed fully. More broadly, the Tallinn SUMP wanted to provide novel technologies for mobility, for example, electric or hydrogen buses, local electricity generation, and for the infrastructure. If there is not fast public transport or network of pedestrian bicycle roads, then citizens will use cars instead, which both remained mainly at the visual thinking level. In the case of processes, Tallinn SUMP indicated two complex decision-making process with vague responsibilities. In theory, the process was well planned, but it lacked political and high-level ownership and strategic management competencies. It was also stated that there was too limited involvement of key city departments and stakeholders. The key objective was to provide, in the case of objectives and values, the key objective was to provide a mobility strategy for the entire region with a focus on environment-friendly goals, including walking, bicycling and public transport, and also setting focus on multimodality. More specifically, the aims to attract approximately 50,000 car drivers to use other means of transport. Tallinn SUMP, seen as a long-term visionary agreement how to organize urban mobility with smaller environmental footprint in the city where population increases. Importantly, urban transport is not a standalone process but closely integrated within the city. For example, kindergartens, waste management, recreational areas, office spaces, and so on. So it needs to be openly discussed and agreed upon. In the case of staffing and skills, according to one respondent, the biggest miscalculation was the assumption that one lead expert can coordinate the full process that triggered the need to change the strategy and add more people to the coordination and analysis team. Importantly, the role of the government was underestimated. They are to be the ones to make larger investments into infrastructure and new technologies. In the case of management systems and structures, according to several interviewed experts, the city council was effectively involved in the last stage. It was also good to have morning seminars, although there was too limited involvement of stakeholders and also limited use of digital technologies for the involvement and decision-making purposes. It also came out that city and government executive decision makers should have been more involved, for example, mayor's office or department heads. It was commonly stated that there were too limited steering committee meetings and open discussions with stakeholders. Despite the lack of strategic management, the wish was to bring the mobility management on a new qualitative level via internal process innovation. Fortunately, city decision makers did not have a clear ownership in this process. Only last period, the deputy mayor was briefed once in 3 weeks. Other resources. According to interviews, there was too strict timeline. It took Helsinki 15 years, and now it was expected Tallinn to deliver a strategic mobility plan in 2 years. In addition, there is too big internal planning fragmentation. There are also other mobility-related action plans. For example, parking, bicycle roads, car logistics, and so on. The SUMP is also linked to the European Commission funding in the new period. Cities without SUMP might have difficulties. Coming to the conclusions, this paper is analyzing the governance processes within urban mobility strategy setting, with additional interest in the application of ICT-enabled tools. The European Commission has initiated Sustainable Urban Mobility Plans initiative from the top-down approach, with a claim that future mobility investments are directed only towards cities with accepted SUMPs. This also triggered the development of SUMP Tallinn. The case this paper was interested in. As a research approach, an ITPOSMO or Design Reality Framework was applied that has been used within the e-governance project's evaluation. Data was collected via document analysis of project files and by conducting expert interviews with key actors in the process. Results indicate that the SUMP Tallinn was planned with wide stakeholder involvement, including the use of digital tools. Reality, however, was different. Most of activities remained within a small project team with too limited internal, political and top-level involvement from the city executives and external involvement, neighboring regions, central government, companies, NGOs, universities, and also, most importantly, citizens. In addition, the adoption of digital tools for analyzing mobility of citizens remained significantly weaker than planned. For example, instead of validation and GPS data positioning of mobility of people and parking spaces, most data was gathered via traditional telephone mass surveys and physical observations. This work has been supported by the European Commission through the Baltic Sea Interreg project Finest Smart Mobility and the Horizon 2020 project Finest Twins. Thank you very much for your interest and look forward to your questions, comments and further presentations.
Hello, my name is Haesun Lee. I'm a PhD student at the University of South Florida. The University of South Florida is located in Tampa, Florida, in the United States. My co-author, Dr. Shriram Shalapan, is my advisor at the University of South Florida. The title of my paper is Computer Vision Assisted Approaches to Detect Street Garbage from Citizen-Generated Imagery. First, I'll talk about 311, which is the data set for my study. 311 is a one-stop municipal service where citizens can report non-emergent issues around their city. The image dataset used for our study was collected from San Francisco 311, which provides multiple communication channels, such as phone, mobile app, web self-service, and Twitter, which allows citizens to upload related images. The 311 request information are available to the public. So this is about the dataset we used for our study, which is from San Francisco 311, named SF311. We collected total of 3.7 million 311 requests dated from July 2008 to August 2019. Out of these, there were 1 million requests with images uploaded by citizens. And out of 1 million requests, 952,000 requests were from mobile app. So side note is that out of all the requests from mobile app, 80% of them had related images uploaded by citizens. So you can assume that majority of the images were taken from mobile app, and we wanted to find some kind of useful information from these images, and we would like to find what's the concern for the citizens in San Francisco. And we found that number one service type for these 1 million images was loose garbage. And we also found that box or bagged items subtype was counted 42,000 requests, and garbage can overflow subtype was counted 21,000 requests. So from this, we can conclude that citizens in San Francisco, they are concerned about cleanness of the streets. It is because garbage related things on the streets are very unsanitary. They can attract bugs. Also, they are hazardous to public health. So we decided to design a model to detect these garbage related objects. So we chose these 4 classes out of the findings, out of the 311 requests with images. So first class is cardboard box, which is related to boxed or bagged items subtype, service subtype. And we chose garbage, which was related to loose garbage service subtype, which was the number 1 concern in the subtype in requests, 311 requests with images. And we also chose garbage can and garbage can overflow, because garbage can and overflow subtype also had 21 requests. So after we chose these 4 classes, we picked 2,500 related images containing these 4 classes. And we divided 90% of images for training and 10% for validation and testing. And these are the number of objects in these images. So we chose most number of objects in garbage to compare to other classes, because garbage was the hardest class to detect, because the garbage have very random and vary in shapes and colors. That's why garbage was the hardest class to detect. So that's why there's more number of objects in garbage. After we picked 2,500 images, we manually annotated images using the tool called Label Image. So that's LABELIMG. This tool is free and open sourced, and it's easy to use and straightforward. That is why it is one of the widely used image annotation tools for object detection. So after we labeled images, we decided to use this methodology called transfer learning to come up with an object detection model. Current state-of-the-art object detection models are based on convolution neural networks, which is one of the technology in deep learning. Because CNN is a deep learning technology, it requires a lot of data and computing power for training their models. So it is time consuming and expensive. To remedy this problem, transfer learning can be effective. So transfer learning is to train a model using efficient pre-trained models. So for our study, we used two very successful pre-trained models. They are faster RCNN and RetinaNet. So faster RCNN was proposed by Ren et al. In 2014. It gained a lot of interest within the computer vision community by winning many competitions in 2015. In this fully connected layers are shared by region proposal network and a fast RCNN detector to enhance the running time. The RPN generates region proposals with different scales and aspect ratios using anchor boxes, different anchor boxes. So this is the architecture of faster RCNN. Another pre-trained model we used was RetinaNet. RetinaNet was proposed by Lin et al. In 2017. It tackles the problem that one-stage object detection models fall behind in their accuracy compared to two-stage models. So for between two pre-trained models, faster RCNN is a two-stage model. That is why it performs with high accuracy. RetinaNet is actually a one-stage object detection model. However, it still performs with high accuracy. It's because it uses focal loss, which focuses on hard and incorrectly classified examples by downweighing easy examples during training. So this is the architecture of RetinaNet, and this is the graph showing the focal loss. So CE is cross entropy loss, and the cross entropy loss is the common loss function used by many object detection models, including faster RCNN. And in this graph, the blue curve is cross entropy loss, and the lines, the red, yellow, purple, and green, these curves are different focal loss functions with different argument value. As you can see, cross entropy loss and the focal loss here with well classified examples, the loss values does not vary as much. However, with the more difficult examples, the loss significantly decreases with focal loss. That is why RetinaNet works well and performs with high accuracy, even though it is a one-stage object detection model. So we decided to use these two effective pre-trained models for our object detection model. These are the evaluation metrics to compare these two pre-trained models, faster RCNN and RetinaNet. MAP is short for mean average precision. This is the mean of average precision of 4 classes. IOU is intersection over union. So this IOU is used to decide the detected box is correct or incorrect. So the idea is that when the detected box is closer to the ground truth box, the IOU gets higher. So when the IOU is higher than 0.5, it is considered correct. But if IOU is lower than 0.5 for each detected box, those boxes will consider as incorrect. Precision is defined as number of correct predictions over number of all predictions from the model. And recall is defined as number of correct predictions over number of all ground truth objects. So this is the results we got with the faster RCNN and RetinaNet. Faster RCNN, the highest MAP was 0.78, whereas RetinaNet, the highest MAP was 0.87. So this shows that RetinaNet returns the better results than faster RCNN. And this is some examples, detected images, examples of detected images. In each image, these are from faster RCNN. For each image, left side image is the detected image and the right side image is ground truth image. And these 4 images are with objects detected with no error. So these are the correctly defined images, correctly detected images. And these 4 images show that the images with objects with some detected object with some errors. So for first image here, the plant pot is should not be detected, but it's detected as garbage can, so that's incorrect. The second image, the plastic box should be recognized as garbage, but in the detection, it's not. This box is detected as cardboard box, so that's incorrect. And the third image here is that the black garbage is not detected in here. Also, these 2 garbage should be detected as just 2 boxes, but as you can see, this is detected 4 boxes, 4 different boxes. And in this case, only the boxes with the highest IOU, which is the detected boxes with closer to the ground truth boxes, will be considered true positives, and the other boxes will be considered as false positives. So if you see, you can see there's 4 boxes detected for these 2 garbage objects. Then these 2 boxes with the closer to the ground truth boxes are considered true positives, and the other 2 boxes will be considered false positives because they have lower IOU. And the fourth image here, this area, it should be just 1 garbage. It should be detected as garbage, but as you can see, there's many boxes detected. So the box with the highest IOU and with the correct class detection is considered true positive, but all the other boxes will be considered as false positives. And these are the results from RetinaNet, and the boxes are color coded in here. The blue boxes are ground truth boxes, green boxes are true positives, red boxes are false positives, and yellow boxes are false negatives. So ground truth is the box that we manually selected and categorized, classified, and the true positives are the correctly detected boxes, and false positives are the boxes detected but that's incorrect, and the false negative boxes are the boxes that should be recognized, however it's not recognized or detected by the model. So these 6 images are the examples that object detected with no error. These images have objects detected with errors. The first image, this cardboard box was detected. However, there's another red box was detected as cardboard box. Since the red box has lower IOU, that's why it's considered false positive. And this red box, the red object, means that the retina net failed to detect this garbage object. This second image, other objects are detected correctly. However, this object should be detected as garbage, but it has good IOU, but the class was detected as garbage, the cardboard box, which is incorrect. That's why this is red, colored red, false positive. And this third image, the green boxes means that they are detected correctly, true positives, but yellow boxes meaning that they should have been detected by the object detection model, the retina net, but they are not recognized. That's why they are considered false negatives. And in fourth, this example that this garbage can is detected. So there is a green box here, but this red box is also detecting garbage can, but this IOU is lower than 0.5, so this is considered false positive. That's why it's red. And in this one, this is garbage, and as you can see, there's blue box, so it's actually recognized, it is detected garbage, but there's a red box is also detected. When there is more than 2 boxes detected for one object, the higher IOU, the box with higher IOU is considered true positive, and the box with lower IOU is considered false positive. So basically the IOU is higher when the box is closer to the ground truth box. And this example also, this garbage is detected and the cardboard box is also detected. However, there's another box, is red box, is detected as well. That's false positive because the IOU is lower, because this is far from the ground truth box. It's not similar to ground truth box. So the last image here, the green boxes means that those are detected, but these objects are not detected because this should have been detected as garbage and cardboard box, but the retina net recognizes total as garbage, and because this is IOU is low, so this is all considered false. So it's false positive. So this is future work for our study. In the future, we can include more classes to detect, such as human waste. Secondly, we can expand our model and database image to other cities. Thirdly, we can incorporate GPS location information with image data and make a connection with socioeconomic factors. So in conclusion, our study demonstrated how to utilize 311 images uploaded by citizens to perform garbage-related object detection using pre-trained models, namely Faster RCNN and RetinaNet. RetinaNet outperformed Faster RCNN with MAP of 0.87. This object detection on garbage can be used to facilitate automatic garbage detection. Thank you. So this concludes my presentation for my paper.
Hello and welcome to my presentation, Identity Inclusion, the Digital National Identification for All. My name is Andrew Armstrong Musoke, together with my co-authors Martin Saint and Patrick Dushimimana from Carnegie Mellon University, Africa. Before we dive in, I'd like to ask you a question. Who are you? It's a question we do not think important often, but how many days can you go without being asked this? Let me walk you through how it would work in the world of identification. First, you as a person, you make a claim, and this is talking about who you are or who you want someone else to think you are. And then you back this claim up with an identification, which could be a passport or an ID, which contains a unique attribute about yourself. That could be your name, your height, or your age. This unique attribute, an identity, authenticated or validated by an authority. This could be the police or someone at your workplace. When that is validated, then your identity is considered proven. But as we can see, who we are is tied to what we carry. But then what happens when you cannot prove who you are simply because your ID is lost, damaged, or your identity is too much to carry around, it's too cumbersome? Or what if you carried the right document to the wrong authority? For example, if you carried your passport and went to the traffic authorities. The solution to this is pretty simple. It's just make sure your identity is tied to something you will not forget to carry around. For example, you could tattoo your ID to your arm. As the world moves to become increasingly digital, we find a need to talk about digital identity. Simply, this is who you are in a networked or online setting. This, however, is much harder to authenticate identity and attributes for a digital identity. That is why companies like Sovereign Foundation have embarked on digital identification implementations using blockchain technology. This is also because they've realized that it is an enabler for digital transformation in institutions like banks and government. So let's take a step back to what we currently know and have. Developing countries, many developing countries like Rwanda, for example, require citizens to carry government-issued plastic IDs. Rwanda has done this since 2008. This ID is required to access various civil services like national insurance or things like that. But acquiring one involves multiple trips, a fee, and a patient wait in most countries. Although Rwanda has an online platform called Irembo that helps citizens access different e-government services like national ID issuance rather. Not all developing world citizens are that lucky. Most actually have to endure a couple of hurdles and an expensive fee, relatively expensive fee. So what we do see here is that the national ID is not a sufficient form of identification for all civil services. For example, in the case where you have a passport and you want to get service from either your insurance company or a police officer, right? You would need to have a relevant identification. In this case, it would be an insurance card for your insurance provider, or a driving permit or a driving license for the police officer. That means that the citizen would have to carry around multiple forms of identification, which mostly duplicate the same information. Then we find that authentication is then challenged by a lack of interoperability between civil service providers. Another thing is the physical card itself is an issue because it could get lost, it could get damaged, it can be forged, and also in an increasingly digital world, as we move to e-government and online services, we find that this physical document does not interface well or scale well with the rest of what we want to do. So we realize that we need a resilient, scalable platform for government-controlled digital identity that works in the developing world. So let's break down these requirements. When we talk about resilient and scalable platform, this is because it's going to be a nationwide software or solution, meaning that's why it needs to be resilient, needs to be up all the time, because people will rely on this. For government-controlled digital identity, this is because national identification scheme is also a role or is required by the government to be able to control that identity, so that it can know who its citizens are, as well as authenticate who they say they are. That works in the developing world. This has a couple of it has a couple of meanings, because when we look at the developing world, we find that we do not have a high prevalence of smartphones, we don't have a high prevalence of internet penetration, as well as computer literacy, and each of these has their own impacts, as we shall see later. So when we think about the requirements for transparency, immutability, and resilience of records, the first technology that comes to mind usually is blockchain. Blockchain is a distributed, decentralized, and public ledger. It's a tried and tested technology that provides the qualities that we wish to achieve in our objectives. So for this paper, we focused on demonstrating the technology without attempting to address the policy and socio-economic challenges that come with with implementing a blockchain-based national identity scheme. But although it's not our intent to minimize the non-technical challenges, we do know they exist. Instead, they do exist outside the scope of this paper. There have been a couple of solutions. People, organizations, and governments have tried to solve the issue of digital identity. Although the current solutions are inappropriate in the context that we set, the context of a developing world, some of the issues we find are reliance on physical IDs, for example, show card, which requires the user to have an already government issued ID. Poor user experience. This in previous works by Dunphy realized that the cryptographic keys that are used by most of the solutions, users find it difficult in case the key is lost, or they need to have a prior knowledge of cryptographic how cryptographic encryption works, so that they can be able to use the solution. Then the issue of self-sovereignty, we already noted that we would like the identification to be government controlled, at least to an extent. Self-sovereignty, which would grant the user or the owner of the identity full rights to issue or reject access to the data, would be an issue for a government controlled solution. Then all the solutions are smartphone dependent, which brings an issue with the fact that we are in the context of a developing country which has low prevalence of smartphones. And then none of the works so far are aimed specifically at interoperability between service providers. So as we were looking through trying to get our proof of concept off the ground, these are the tools that we used for the test environment. Ganache, just a personal blockchain for testing and deploying contracts. Truffle, which is the development environment and testing framework. MetaMask, which allows running Ethereum distributed applications in a browser. Then Web3.js, which is a collection of libraries which help us to interact with the Ethereum blockchain over HTTP. And then finally, the Ethereum blockchain, which is the distributed ledger of choice. In this case, allows us to run decentralized applications. Works like Schaefer et al. Have detailed performance and scalability tests, and therefore we focus on only the architecture and the process flow for proof of concept. So for the architecture, it's pretty straightforward. The major component here is the government server, which in this case is just an abstraction for the combined computing power under the control of the government. This can be either just the core infrastructure in maybe a ministry, or even as broad as the computers in a local government office. On top of this, we shall run the Ethereum blockchain for if in the case that you're using permissioned blockchains, and then it will also run the government computing resources. Will also run the user interface. In this case, we have two user interfaces. One is a web-based user interface for service providers, like the health workers, police, or government officials, and the other user interface is on the end of the citizen, which in this case is a feature phone. The feature phone interacts with the government server over using the mobile network operators, USSD APIs as a proxy. In this case, no internet will be required because USSD does not use any internet whatsoever. All you need is a feature phone. So going through the process flow, this is a use case, one of the use cases, just to show you how a citizen could sign up, register, and use the service. So number one, you have a citizen physically visit a government office to register with an official government institution. For example, in Rwanda, that would be the Rwanda National ID Agency. Then two, you have the institution verify the citizen's information as they would, and then register the citizen's data to the blockchain. This is done through the portal, which was the UI we showed in the architecture. Then number three, the citizen receives a prompt to input a 4-digit PIN. This prompt is received over USSD. Once the PIN is entered, this will confirm the registration process. Number four, the citizen requests a service from a healthcare center. This could be, say, for example, a government hospital, and they want to get some treatment. The healthcare center in number five requires the identity or information of the citizen, plus, say, the national insurance information if the citizen is on that scheme. This request is then redirected to the citizen in number six, where the citizen will then have to authorize the third party, in this case the hospital, by entering the PIN to authorize them to get the data that they require. The citizen can see what is required, what data is required from them via USSD. Because USSD is sort of it would show the chat. Then number seven, upon authorization, the healthcare center can then confirm the identity and proceed with the services. In addition to requesting citizens' information, the healthcare center can link the medical history or the health data that has been collected to this citizen's identification, effectively creating an immutable and readily available medical history that is not dependent on the healthcare center's information system. The citizen can then walk around with this and go to another hospital and can give them that same medical history. In the case where the citizen does not possess the phone, they can still be identified with their national ID number, which they can carry around in their head, or on a piece of paper. This national ID number is linked to the metadata that is already stored on the blockchain. For this, extra steps would need to be taken to verify identity, things like facial recognition, fingerprint or voice print identification, taking cost into consideration. So for the issue of self-sovereignty, we tried to get a sort of a compromise, and we came up with trust zones. So in the middle, we'll count the zones 1 to 4, starting from the innermost zone, where you have the identity owner who has access to all of the information, all of the data that the citizen has linked to them. Then the second zone is where you'd find the government and the trusted third parties. The entities in this zone have access to legally mandated information, In this case, that is information that, for example, like your date of birth, your location, or anything else that you would find typical in a passport or a national ID. The citizen has no right to deny people or entities in the second zone the data that is required. The entities in the third and the fourth zone. In the third zone, we have trusted third parties. These are service providers, for example, the hospital that we saw in the process flow scenario. This would be a trusted third party from the context of the citizen, where they can choose what information to offer to this trusted third party. In the fourth zone, you find the untrusted parties, which is pretty much the rest of the internet. This zone is not much different in the sense that the citizen chooses what data to give, but it can be made more restrictive to protect more restrictive by default to protect citizens at large. So the trust zones are implemented in the logic of the smart contract. Entities are placed in trust zones by government institutions at the point of registration. Citizens decide what data to share with entities in trust zones 3 and 4 through the USSD interface. So here, for implementation, we can see the list of individuals and the insurance providers. This is what a minimal user interface would look like, where you have name and then the biodata, in this case only the telephone number, and then the insurance that the citizen is on. This data is stored currently on the blockchain. Next, you find Ganache showing how the cost of doing the transaction of adding a user onto the blockchain. This cost approximately $19 by the time we did this. But since we were using Ganache in the test environment, this did not cost us anything since we were not using the public cloud. So we implemented a proof of concept system that can serve as a foundation for a more sophisticated digital national identification platform in a developing country with low smartphone technology penetration. So we see here that we need nothing but a phone or a unique identifier to be able to identify oneself. Accountability for misuse or use of data is possible thanks to the transparency aspect of the blockchain. Expedited audits against data protection policies is possible thanks to the immutable record that is available on the blockchain. This will tell us who did what, when, and where. Then there's a reduction in fraudulent claims, since it is much more difficult by design to forge data on the blockchain than it is to forge a physical ID. And in case forgery is done, the culprit can be found easily, and this is a deterrent. We did find, though, a high cost of transacting on the blockchain, and $19 per transaction was a bit too much. But there are remedies for this high cost, for example, storing data off-chain or using permission blockchains that are not private permission blockchains that are not part of the public blockchain, meaning you use your own computing power and don't pay for any on the public blockchain, on the public network. Then we also realize that our solution is not a faithful decentralized solution as most blockchain applications are, since the government is required to be a trusted third party to do things like registration. In this case, if the majority of the government is trusted, which we would hope for a solution like this to work, that would be a caveat. If majority of the government is trusted, then the minority of the malicious individuals do not affect the functioning of the system. That is not to say they can still, the malicious individuals can still misuse or misuse the system or abuse the system, but they cannot remove the immutable records or alter them in any way, meaning the transparency will act as a deterrent. They can easily be found and easily be subjected to punishments as the law dictates. We did have some trade-offs that we considered during this implementation. For example, decentralization for ease of governance, like I just explained, where we need to have a centralized we need to have some sort of centralization because the government needs to validate the identity of the citizens as they go onto the blockchain. Then we traded off public key security for usability. This is because this is as a result of the discoveries by previous work that the user experience was poor when using public key security, and you can it is safe to assume that the majority of the population is going to be illiterate to the workings of public-private cryptographic keys. Although it is easier to remember a PIN, it is less secure. But telecom companies have set precedent by using the PIN as the de facto way to authorize mobile access to client mobile money wallets. In addition, companies like Chase Bank working on voice print technology, which could be explored as an affordable way to do two-factor authentication over feature phones. We traded off self-sovereignty for ease of governance, because if citizens had full control over their data, they could deny government entities and related trusted third parties legally required information. And we showed how we use trust zones as a compromise. So in conclusion, just to summarize, current national ID schemes lack in interoperability. One has to carry multiple forms of identification to access different civil services. Past efforts for digital identification have been found inappropriate for the context of third developing countries where smartphones are not prevalent. Ethereum and USSD based proof of concept, that is what we came up with and presented. And then we also presented a healthcare use case where a citizen was able to register on the blockchain their identity and then use the same system to go and access healthcare using a national insurance, and then additionally, as a bonus, be able to store their medical data in an interoperable fashion. For future work, we're looking at ways of reducing operational costs. This is to reduce the cost of the Ethereum either through private permission blockchains off-chain data storage. Then more secure ways for the system using novel two-factor authentication methods like voice print identification. And then finally, this work would benefit from a real-world deployment so that it can tackle issues again like socioeconomic or legal adoption issues. Thank you very much for listening to this presentation. Again, I've been Andrew Armstrong Musoke, and with my co-authors Martin Saint, Patrick Doshimimana. Love to hear your questions if you have any. You can reach me and my co-authors at the emails shown there. Thank you very much.
By names of Arnito Irene, I want to thank the conference organizers who have given me a chance to share my research titled A Theoretical Framework for GIS-enabled public electronic participation in municipal solid waste management. The co-authors are Gilbert Maiga and Agnes Nakakawa, and we are all from Makerere University School of Computing and Informatics Technology, Kampala, Uganda. The background of this research that waste generation in most municipalities has tremendously increased due to rapid urbanization and high population growth. In fact, in the year 2012, slightly more than 2.1 billion tons of municipal solid waste were generated, and they are expected to increase to approximately 5 tons by the year 2025. As this poses a serious threat to our health and the environment in terms of air pollution and the diseases that might result in the poor handling of municipal solid waste. Waste management is a key responsibility of the municipalities across the globe. However, some municipalities have not delivered as expected due to challenges associated with funding, infrastructure, and in Africa, 78% of solid waste generated is illegally dumped. In Uganda, which is the case study for this research, half of the waste that is generated is illegally dumped. Several strategies have been devised to address municipal solid waste management challenges, and these include life cycle assessment, cost-benefit analysis, multi-criteria decision analysis, and geographical information system. All these strategies help in locating suitable sites for waste disposal, route analysis in order to know which are the appropriate routes to use to transport waste to the final destinations. However, to achieve sustainability, all these strategies require effective and broader stakeholder engagement in the process. In fact, these days public participation is encouraged in order to have proper governance, and in municipal solid waste management, public participation is an important tool because it helps to identify the challenges at an early stage and they are better handled. The justification of this study is that Public participation, yes, can take place with traditional approaches such as interviews, door-to-door consultations, but these have proved to be very ineffective when it comes to collecting information for planning purposes where spatial information is important. Electronic participation can help solicit views from a wider audience of stakeholders, but public participatory GIS does it better because environmental matters have spatial aspects, thus it helps to solicit all the stakeholder information in addition to their location attributes. However, PPGIS lacks comprehensive theoretical foundation and groundings, especially for its use in resource-limited settings. Therefore, this study sought to extend the enhanced adaptive structuralization theory version 2 in order to come up with a comprehensive theoretical framework that can guide the implementation of PPGIS for planning in municipal solid waste management in resource-limited settings. The methods used for this research, first we used literature review in order to identify the aspects and constructs that have previously proven to inform public participatory GIS implementation, use of GIS in decision making and planning, and thus they were thought to be important for this study. A cross-sectional survey among stakeholders in municipal solid waste management in Kampala was conducted, especially in Kampala's 4 divisions of Nakawa, Kawempe, Rubaga, and Makinde. Stratified random sampling approach was used to select study participants, in which the participants were grouped into different categories, and in each category the respondents were randomly selected. A Likert scale-based self-administered questionnaire was used to collect data to measure the agreement within the 9 latent variables in the proposed framework. The proposed framework on this slide was adapted from the enhanced adaptive structuralization theory, version 2, in which new constructs and aspects that inform GIS decision making, implementation of public participatory GIS were added onto this framework to develop a new one. This proposed framework consists of 3 categories of constructs. The first one are the convening constructs on the left side of the framework. They include socio-institutional influence, task influence, participatory GIS influence, and participant influence. These 4 convening constructs consist aspects that must be in place before a public participatory GIS-enabled process takes place. The second category of constructs in the middle, they constitute the decision process constructs. These are the constructs that explain the actual public participatory process. They include appropriation, which is the actual use of PPGIS for planning and public participation. They include participatory decision process, which is the actual process of engaging the public, and then emergent influences. These are the aspects that are the results of engaging the public, and they are immediately reused in the process. The third category of constructs are the outcome constructs, which include social outcomes and the decision outcomes. These are very important because they tell us the output of a public participatory GIS-enabled process. And in this new framework, the new constructs and aspects are all in bold, and the constructs and aspects that were on the original enhanced adaptive structuralization theory version 2 are not in bold. Continuing with our research methods for this study, we used partial least squares, structure equation modeling, which enables us to analyze data, especially when the framework is for predictive purposes. And we tested the relationship between the different constructs, and it was done iteratively, and the resulting final structure model presented. Internal consistency or the reliability, the tool was measured using Cronbach alpha. Convergent validity was also measured using average variance extracted. Statistical significant level of 0.05 was considered for this study. The relationships in the framework that were tested include PPGIS influence and appropriation of PPGIS in a participatory decision process, public participation influence, and appropriation of PPGIS in a participatory decision process, task influence and appropriation of PPGIS in a participatory decision process, and socio-institutional influence and appropriation of PPGIS in participatory decision process. So the first bullet looks at the relationship between the convening constructs and appropriation of PPGIS in a participatory decision process. In addition, the relationship between appropriation and participatory decision process in a participatory decision process was tested. The relationship between appropriation and decision outcomes in a participatory decision process was also tested. The results of this study include demographics, the reliability findings, validity findings. Now we start with the demographics, the characteristics of the respondents. First, we had more male participants than female. More of the participants had a year of 0 to 10 years of experience in municipal solid waste management practice, and they mostly were degree holders and above. The reliability and convergent validity of the constructs. We looked at appropriation, emergent structures, organizational influence, participatory decision process, decision outcomes, participant influence, social outcomes, task influence, technology influence. They all had a good reliability score of 0.7 and above, and the validity score of 0.5 and above based on average variance extracted method. Discriminant validity of the construct was also conducted, and most of the constructs aspects performed well on their constructs. For example, emergent structures had a good score of 0.776 on its aspects and 0.592 on organizational influence. Similarly, the aspects of appropriation performed well on the appropriation construct is 0.802 compared to 0.631 on emergent structures and 0.491 on organizational influence. So all the aspects performed very well on their constructs. The resultant structure model or the final framework, which was adapted from Enhanced Adaptive Structuralization version 2 is here presented. The task influence, PPGIS influence, participant influence, socio-institutional influence constructs have a predictive power of 46% on appropriation of PPGIS. Appropriation of PPGIS in a public participatory decision process has a predictive power of 64% on participatory decision process construct. All the constructs in a decision process, which include appropriation of PPGIS, emergent structures, and participatory decision process, have a predictive power of 53.9% on decision outcomes and 40% on social outcomes, respectively. So, the predictive power of the model and of the framework based on the new construct was significantly variable in the construct. The relationship, the significance of the relationships tested, so that the results of the significance, the relationships, so that most of the relationships were actually statistically significant, with a score above, with a score less than 0.05. For example, the relationship between appropriation and participatory decision process, you see the result, the p-value is less than 0.001. The relationship between emergent structures and appropriation, we have a p-value of 0.001. Emergent structures and participatory decision process, we also have a p-value of less than 0.01. Only organizational influence and appropriation, participant influence and appropriation, task influence and appropriation relationships were insignificant. For example, organizational influence and appropriation relationship, the p-value is 0.882, which is high, far above 0.05 p-value, which was considered for this study. The discussion and conclusions, finally, we saw that the extended is enhanced adaptive structuralization COA2 includes the spatial planning process, which was embedded in the participatory decision process construct in order to improve on the framework's ability to capture the spatial aspects which are important in environmental decision making. The decision outcome was enhanced to include evaluation aspects that help us to gauge whether the final decision is important or is sound. The aspects that have been previously reported to influence the use of PPGIS in the governmental decision process, especially those concerning the participants, such as computing skills, their attitude, and the digital divide, were added in the framework, and they performed well. A new construct introduced of task influence was also added, and its relationship with appropriation of PPGIS in a decision process was also statistically significant. The results of this study are consistent with prior research that shows that the study is of importance, especially on the use of PPGIS in environmental decision making. However, the framework was tested in urban settings, and this should be evaluated in urban areas that constitute most of the places in rural, in resource constrained settings. PPGIS is still evolving and faces several challenges in resource-limited settings. Therefore, more research is needed into its study its implementation in this context, so as to inform policy and government. The extended model, however, contributes to this research and can contribute to the adoption and implementation of PPGIS applications in resource-limited settings. I acknowledge the support of my study participants, Kampala Capital City Authority that gave me permission to conduct research in Kampala and the 4 divisions, the Swedish International Development Cooperation Agency that funded this research, and Makerere University that admitted me to do my research there. I thank you for listening.
Dear ladies and gentlemen, I am happy to present you today the paper with title Promotion as a Tool of Smart Governance in City. Me and my colleagues, which are the co-authors of the paper, are members of Department of Regional Development and Public Economics from Matej Bel University, Faculty of Economics in Slovakia. And we do quite long-term research in field of local development, regional development, as well as implementation of new trends of local and regional development as smart city, creative cities, and so on. And we now deal with this issue also within the national project, Smart Governance in Local Municipalities, and this paper presented also the partial output of this project. The paper is divided into 3 main sections and then a conclusion. The first part is theoretically oriented, and it defines the promotion tools and its specific as a part of smart governance. The second section introduces material and data used and the research methodology. The third section is devoted to presentation of the research results on mapping the utilization of promotion tools in the Slovak cities as a part of smart governance. This section is enriched also by the examples of best practices. And then a short conclusion, which defines the strengths and weaknesses, challenges of promotion tools utilization in smart governance. The aim of the paper is to define the promotion tools as a part of smart governance in the city and verify its utilization in the cities of the Slovak Republic. The object of the research are Slovak cities. We have in Slovakia 141 cities within 7 size categories from 1,000 inhabitants to more as 100,000 inhabitants. And our research covers all cities which are situated in the Slovak Republic. The first part of our presentation is devoted to the definition of the basic terms. The smart governance, we can say that it is one of the newest trend in the public management and also the management of cities and regions. The development and transformation of public administration is closely connected with the new technological invention, digitalization, or also with a kind of smartness in decision making. And Thus has resulted in this new phenomenon, smart governance, as a part of a smart city concept. Within the deep theoretical research, we identified as one of the most complex definition of smart governance the definition of Roland from 2018, which defined the smart governance as a procedural interplay among a diverse set of stakeholders equipped with different roles and responsibilities organized in various external and internal structures, an organization driven and facilitated by technology and data, involving certain types of legislation, policy, and exchange arrangements for the purpose of achieving either substantive output for cities or procedural changes. It is quite long definition, but the main idea is that the smart governance is based on the participation of a wide range of stakeholders. This participation is based on the utilization of technology and data, and very important is to create enough suitable legislative framework and also to prepare all conditions to realize the exchanges between the stakeholders. The other authors also define something like a main precondition which are necessary to implement in the cities if we want to say that there is a real implemented smart governance. It includes the necessary city infrastructure that included the access to the information as well as the technology which allow this access to the information. Also, the government in the smart city should harmonize management, governance, and policy with other factors that influence the implementation of public policies, which are connected with the development and involving different stakeholders into the development. The second precondition is that to implement the smart governance concept is possible only when we have enough financial, material, technological, natural, or human resources. And the last one is human capital that is very important also as a part of local authority, that the employees has to be skilled and have experience in this field. On the other hand, also the other stakeholders, citizens or businesses, non-profit organization, they have to be able to use their skills and also to use the tools of smart governance, and by this way to influence the public policy creation. All activities which include the smart governance can be divided into the two main areas. The first one is participation in public policies processes, and the second one, the involvement in improving services in the city. Participation of stakeholders increases openness, transparency, accountability of local authority, and thus the quality of relations between stakeholders and local governments. Very important for this purpose is that the government collected the data about the stakeholders, their needs, about the situation in the city, and then share them and somehow exchange with stakeholders, and use this knowledge to support evidence-based decision making. Then enables government to make more informed decisions and improve the efficiency of public policies and programs. When we speak about the creation or co-creation of public services, it can help increase the city competitiveness and citizens' quality of life. And innovative services provide to citizens with information, knowledge, and action related to various aspects of their city life. Both groups of tools, these one which are oriented on participation and also these one which are oriented on co-creation of smart city services, increase stakeholders' abilities to participate in governments in all phases of public policy, and it can help decision makers also to make better decisions and meet the needs of the population. However, what is very important is also the use of information technologies for the purposes as we described. It is necessary to publish and share transparently all data and information about the local municipality. And the link between transparency and smart cities lies in both in technology and also in information that is truly transparent and digitalized, making it easier to find and use. Both on the literature reviews and identification of authors that deals with the topic of smart governance, we try to define the tools of smart governance, and we can divide them into these three groups. The first one is or are modern forms of e-participation and e-democracy. As you can see, it is electronic e-voting, e-petition, e-referendum, or chatting rooms, electronic civil boards. The second one are these which support the decision-making process. It can be like electronic advisory election, quick poll surveys, or simulation of decision making. And the last one are the tools that strongly influence the decision of stakeholders to participate, and we can say they are closely connected with the promotion tools because they have also the information function and also the function to persuade and involve the stakeholders into the public policy decision making. To these tools, we can include also the forms of promotion tools and communication channels, as well as various mobile application, digital platforms, which are very fashion these last years. Like tools of smart governments, we can say that this definition can be used. Why we choose or why we connected it with the promotion is that the promotion is by many authors used as one of the most important tool of local municipalities and cities. And also these promotion tools are very progressive developed. It is caused also by the development of information technologies. And when we interconnected these promotion tools with the definition of tools of smart governance, we can see direct link. Because a lot of these tools somehow supported the decision of stakeholders to be involved into the public policy decision making and also to inform the stakeholders about the situation, about the possibilities, how to influence the public policy. To the definition of promotion tool, we used our definition, which is based on our previous researches of marketing communication in the cities. And as a modern tools of promotion, we define the public relation, advertising, sales promotion, personal communication, events, virtual communication, direct mail, word of mouth, mass communication, viral communication, guerrilla activities, product placement, and mobile communication. On the slide, you can see also the aim of each of these tools and also the form which are usually used in local municipalities. In our research, we oriented on definition or verification of this definition of tools of smart governance and new form of promotion in real condition of cities of Slovak Republic. For the definition of smart governance tools and promotion tools, as you could see, we use quite deep literature review. It helps us to categorize the tools and identify the mutual penetration of both tools of categories. Then we selected the tools which are the probably the most used tool and popular tool in Slovak Republic. We used also our previous researches to identify these items. And the research was done during the April, May, and June 2020. As a source of data, there were the city website is all these profiles of different social networks as Facebook, YouTube, or Twitter. And we use the method of observation, analysis, and comparison, synthesis, and reduction. This research, primary secondary research, was complemented by some examples of best practices in smart governance in the Slovak cities. So, as I said, the research was done in 141 cities. In Slovakia, we have only 2 really big cities. It means that these cities have more than 100,000 inhabitants. The most of the cities belong to the size categories from 5,000 people to 50,000 people. It is almost 70% of all Slovak cities. On the first slide, you can see the information about the utilization of all research promotion tools. As you can see that all of the cities, they have own web page. It is also something like a rule defined by the legislative that each city has to have a website. As the second most used tool are events and organization of events. The highest share of Facebook exploitation in cities confirms the fact that the Facebook is the most often used social network in Slovakia. And also more than 50% of cities use mobile application, discussion forums, chats, and blogs, as well as YouTube. Now, the least exploited tools belong digital advertisement and local placement. Maybe it is because it is something more also more expensive for the cities and maybe not so relevant because it is more applied in the field of private sector. When we see the exploitation, see the partial results of the research, we divided them on the exploitation of the social networks and then other research form of promotion. So by the exploitation of the social networks by the cities regarding the size category, we can see that all bigger cities, it means that the cities with more than 50,000 inhabitants use for promotion Facebook, Instagram, YouTube. Both the biggest cities, it is the capital city and the city Košice, use also the Twitter, LinkedIn, and Tumblr. Bratislava has even 2 profiles on Facebook and Instagram, one oriented on the citizens and the second one oriented towards tourists. The higher number of followers is indicated in case of tourist profiles of Bratislava. The most used social network in cities of all sizes is Facebook. More than 50% of cities in each size category use also channels on YouTube, except cities with 5,000 to 10,000 inhabitants. And Twitter and Instagram are not so popular networks. In smaller cities, it means from 1,000 to 50,000 inhabitants. To the other exploited social networks by small number of cities belong Pinterest, LinkedIn, Tumblr, Gmail, or Yahoo. I think also these research results confirm the situation in Slovak Republic that there are prefer more the networks like Facebook, Instagram, and YouTube, which are really the most popular among population. When we see the information about the exploitation of the older research forms of promotion in Slovakia, we can see that the second most used tool almost in all cities in each category is organization of events, and also it is followed also by the second tool, mobile application of cities. The share of cities with the mobile application is lower in smaller cities, so this application is more preferred in bigger cities. Only approximately half of the cities uses also discussion forums, chats, and blogs, and in big cities are also these forms of promotion more frequently used, like in smaller cities. These are the research results, and I would like to add also some information about good examples because we really can say that there is no possible to say that in some Slovak cities is implemented smart government or governance as a whole only by the partial activities. One of these is also the project in the Trnava city. It is a seat of regional government also, and they implemented in 2020 a project which is oriented on collection of different kinds of information that are provided to the citizen in the form of website, and during this month also they prepare mobile application. So it is a platform that distribute the information, various information about the environment, about the weather, about the public services, about the traffic, about the decision of local government to the city. And we find also some information about the cost of this investment. It was 116,000 euros. As a second example, we choose the example from Trenčín. This city is quite progressive, and they really strong work on preparation of smart city strategy, not only for the city but also for the region of Trenčín. And they also introduce a chatbot, a computer program that simulates a normal conversation between people. And this chatbot is used for sharing information of local municipality with citizens. Also, there is possible to inform citizens about the culture events, about the news, about transport, notification about repairs of roads, for example, comments on the official board of the city, or about the decision of the city council. And the implementation costs are estimated at 65,000 euros, and I think it's also a very nice example how also by small steps you can contribute to develop this smart government concept in city. And the last one is like a general application that is provided by the private company for the Slovak cities, and now its application is already used in 21 Slovak cities. It is a first kind of this platform in Slovakia that provide the possibility to personificate the application for the condition of the city, and the information that city can provide by this application include a lot of information about the communal life, about the information on culture, the information of official board, reporting the problems, or even also, for example, neighborhood exchange or some buses arrivals, departures. So it is quite complex mobile application that is accustomed to the need of the city. This application is already used also in bigger Slovak cities like Trnava, Nitra, Žilina, Bratislava, which are the seats of regions also, but also in smaller cities like Lučenec, Moldava nad Bodvou, or smaller villages. You can see also on the pictures that the form of this application is quite uniform, and it's differentiated, for example, by color to the city. To conclude the presentation, I would like to stress that also in Slovakia we can find the cities that want to be innovative and want to be in line with the progress in development of new trends in regional local development, as well as in implementation of new information technologies. It is the agenda of smart city and the smart government is quite broad, and there is still a great place for the Slovak cities how to improve the situation. To the strengths, we can say belong that the Slovak cities implement and use various kinds of information channels and form of promotion. They try to combine the traditional one with the new one based on the information technology. But to the problem areas, we can identify the problem of quality of human resources, especially the people who work in the local municipalities and their abilities and skills to use the new information technologies. And also by this argument, there is a great limitation of implementation of this new progressive form of promotion and smart governance into the local municipality. Very difficult. The second problem is that till now the cities realize only some partial activities like this mobile application or some kind of platform to collect the information. But if they really want to be smart and they want to have a smart government, the priority is to prepare the global complex document that will define the steps that are necessary to do to become really smart. And so part of these smart strategies or smart governance strategies should be also the communications plans, how to inform the citizens and stakeholders and how to involve them into the smart governance activities. But still here can Slovakia find a lot of good examples from abroad that can be somehow accustomed to the condition of Slovak cities, but they can try to implement them and to find maybe some more suitable solution how to develop the smart governance concept more easy or even in higher quality as well as the cities abroad, which are like pioneers and the best practice examples abroad, like Berlin, Vienna, Amsterdam, Stockholm, all. So thank you very much for your attention. I hope that you enjoyed the presentation. And if you have also another question or are you interested in our research, please do not hesitate to contact us.